Hello students, now we'll be solving question paper of 2011. Okay, so this is a CBSE mains exam. There are two exams for medical, that is mains and prelims. So we'll be solving mains part specially. Okay, NEET was introduced in 2014, from 2014 actually. It's 13. So please look at the questions. There are 30 questions out here. So we'll be solving one by one. Question number 1 actually starts from 61 till 68 was biology, and 61 starts with physics. Now let us see question number 61 at first. A galvanometer of resistance G is shunted by a resistance S ohm. To keep the main current in the circuit unchanged, the resistance to be put in series with the galvanometer is how much? Now what you have to do? You have to know the question from which chapter it came. It came from the chapter what? Magnetic effects of current, that is moving coil galvanometer. If you study from there only, you can get this topic. Conversion of galvanometer into voltmeter, conversion of galvanometer into ammeter, those are the subtopics which was there. So how we are going to proceed this one? G will be equal to Gs divided by G plus S plus R. Now you need to calculate this R. So when you calculate after this, you will see that the right answer for this one will be this. So this is the correct option for question number 61. Now let us move to the next question, that is question number 62. Question number 62 says that a particle covers half of its total distance with speed v1 and the rest half with speed v2. A particle is moving, half time it covers with the speed v1 and the next half it covers with v2, speed v2. Its average speed during the complete journey is. So again, this is a question from class 11, motion in one dimension, right? So how do you solve this one? This is simply, you can write down as twice of S. This is the total displacement it will cover, then S by V1 plus S by V2. Yes or no? Divided by this. So once you solve this one, you will see that the right option for this one will be twice of V1 into V2 divided by V1 plus V2. This is the average speed. So this is nothing but total distance, or total distance by total time taken. So fine. So this is how you can solve this one. Now let us move to the next question. A thermocouple of negligible resistance produces an EMF, which is given here, in the linear range of the temperature. A galvanometer of resistance 10 ohm whose sensitivity is this much is employed with the thermocouple. The smallest value of temperature difference that can be detected by the system will be. So it's a kind of mixed question. I want to try this question. So please try this question whenever you see this. But let me tell you the right answer for this question. The right option will be option number 2, that is 0.25 degrees Celsius. This is the right answer. Now let us move to the next question, that is question number 64. A mass m moving horizontally along x axis with velocity v collides and strikes to the mass of 3m moving with velocity moving with vertical velocity upward, okay, with velocity given to be twice of v. The final velocity of the combination is. So how you are going to solve this question? This is again a question from the topic collision, where you can find out in this way: mv, that is m1 v1 plus m2 v2 divided by m1 plus m2. This is the formula which we will be using. So your m is how much? For first m is m, then it was moving with velocity v along the direction x axis, that is why I cap. Then the second one, the mass m2 will be 3m, and the velocity is given out here is twice of v along j cap divided by, that is m plus 3m, 4m. So out here mm get cancelled, so your answer will be v I cap by 4 plus, again 2 and 4 get cancelled out, it will be 3 by 2 v j cap. So look for the correct answer in the option. So 1 by 4 v I cap, 3 by 2 v j cap. Option number 3 is the correct answer. Now let us move to the next question, That is question number 65. A converging beam of rays is incident on a diverging lens, that is a concave lens, right. Having passed through the lens, the ray intersect at a point 15 centimeter from the lens on the opposite side. That means your image distance is given out here to be opposite side of the lens, that will be plus 15 centimeter. Remember, this is a question from the chapter ray optics. If the lens is removed, the point where the rays meet will move 5 centimeter closer to the lens. Okay, if the lens move closer, where will be your object distance then? Right, you can find it out from here only, that is 15 minus of 5 centimeter. So, your object distance out here will be u, that is u will be minus 10 centimeter, 15 minus 5, but minus sign is attached because it is the object distance against the ray according to sign convention. Now, you need to calculate the focal length. So, which formula you will use? 1 by v minus 1 by u is equals to 1 by f, right. The right answer for this question will come out to be minus 30 centimeter. So, number 1 is the correct answer. So, you proceed next, just put the values and find the answer. Now, let us move to the next question, that is question number 66. The threshold frequency for a photosensitive metal is 3.3 into 10 to the power 14 hertz. The threshold frequency is given to you, that means your mu naught is given to you, the value is given is 3.3 into 10 to the power 14 hertz. That is the threshold frequency of the metal. If the light of frequency 8.2 into 10 to the power 14 hertz is used, now then another frequency is given to be 8.2 into 10 to the power 14 hertz. Okay, this is the main frequency is incident on this metal. The cutoff voltage, that is your V naught, you have to calculate, and for the photoelectric emission is nearly. Okay. Now, you need to calculate the cutoff voltage. For that, what you have to know is from which chapter this question came. This question came from the chapter dual nature of radiation and matter, okay, and the topic is Einstein photoelectric equation, where you will be using kinetic energy. We know that h mu minus h mu naught, and we know kinetic energy can be written as EV naught h mu minus h mu naught. So, your V naught will be equals to h mu minus h mu naught divided by E. If you use this formula, your correct answer will come. This is V naught, that is the cutoff voltage, and your right answer will be 2 volt. The correct answer will be 2 volt for this question. So, I will click on 2 volt. Now, let us move to the next question, that is question number 67. An electron in the hydrogen atom jumps from excited ends to the ground state. Okay. The wavelength so emitted illuminates a photosensitive metal have work function how much? 2.5 electron volt. If the stopping potential of the photoelectron is 10 volt, then the value of n is, you have to calculate the value of n. So, how you are going to approach this question? For that, you need to know, we know that total energy E n is given by, for hydrogen atom, 13.6 divided by n square. First of all, this is a question from the chapter atoms, topic Bohr models of hydrogen atom. Okay. Now, total energy can be calculated. Total energy will be, that is E n will be equals to, first due to the first energy level, it is grounding to the ground state. So, it will be 13.6, n will be 1, plus due to the work function, it will be 2.5, plus given how much? It is 10 stopping potential, which will act like your energy, right or not. So, if you solve this one, it will be 0.85. Now, you put it in this equation, 0.85 is equal to minus 13.6 divided by n square. So, minus is just the magnitude. For the consideration of magnitude, we can remove this minus sign, because orbits, number of orbits will never come in minus. If you solve this one, your final answer n will be equals to 4. So, the right option for this question is option number 4, which is 4. This is the correct answer. Now, let us move to the next question, that is question number 68. 8. Question number 68 says that the RMS value of potential difference V as shown in the figure is. If you take the formula, this is a question from alternating current where you have to find out the RMS value, which will come out to be V naught by root 2. So root 2 will be this one because the option is not given, so it will be root 2. So this is the correct answer, option number 4, V naught by root 2. Now let us move to the next question, that is question number 69. A particle of mass m is situated at the center of the spherical shell of same mass and radius a. The magnitude of the gravitational potential at a point situated at a by 2 distance from the center will be how much? So you need to calculate the gravitational potential till the center, till the radius a and the radius a by 2. So potential is a scalar quantity. So we can add up directly what it will be. So your gravitational potential V will be equal to Gm by A by 2 plus Gm by A. Now if you solve this one, you will see that the correct answer for this question will be, if I take 2 up, 2 Gm by A plus Gm by A. So once you solve this, the right answer for this one will be come out to be 3 Gm by A, right or not? If you take LCM A, fine. Let us now move to the next question, question number 70. 70 says two particles are oscillating along two close parallel straight lines side by side. Fine. Hope you understood this part. With the same frequency and amplitude. The two particles are vibrating with same frequency and amplitude. They pass each other, moving in opposite direction, where the displacement is half of its amplitude. What will be the displacement? Half of its amplitude. The mean position of the two particles lie on this straight line perpendicular to the path of the two particles. The phase difference of the particle you have to calculate. For that, what you are going to do? How you are going to approach this question? This question came from the topic simple harmonic motion. You have to use this formula, x is equals to a sine of theta. Now this x can be written as half of its amplitude means a by 2 a sine of theta. A get cancel out, sine theta will be equals to half. So your theta is coming out to be 30 degree. So if the phase shift was there, it will be 180 degree, right? So 30 has gone, remaining how much? 150. So what will be the difference? So I can say the theta will be for one 30 and the other one will be 150. So your phase difference phi will come out to be 150 minus 30 degree, that is 120 degree. So 120 degree is the correct answer. Now you see which option would be the correct one. If you see the option number 4, that is 2 pi by 3, 2 into 180 divided by 3, then it will come out to be how much? 120 degrees. So option 4 is your correct answer. Now let us move to the next question, that is question number 71. 71 says that in the circuit shown in the figure, if the potential at A is taken to be 0, the potential at B will be how much? Okay. Now this is a question from the chapter current electricity. So if you solve the circuit using KVL also you can say solve, that is Kirchhoff voltage law. In the circuit shown in the figure, if the potential at point A is taken to be 0, that means at point A the potential is 0, then you have to calculate the potential at point B. Fine. So take up these 2 points A and B. You can take the loop as well, using Kirchhoff's voltage law also can be solved, and you can find the final potential at B. So the right answer for this question will be plus 1 volt. So I want you to try by yourself, easy question, right? So now let us move to the next question, that is question number 72. A conveyor belt is moving at a constant speed of 2 meter per second. Okay, its initial velocity is given to be how much? 2 meter per second. The box is gently dropped on it. A particular box is dropped on it. The coefficient of friction between them is mu equals to 0.5. The distance that the box will move relative to belt before coming to rest, taking g equals to 10 meter per second square. So how you are going to approach? It's a combination of friction as well as the equation of motion you have to use. So what you will do, first you will check for the acceleration. Acceleration is equals to minus g of your coefficient of friction. From there, if you find out the acceleration, you need to use the formula v square minus u square is equals to 2as. These two formula you will be using out here, and you will see that the right answer for this question, after getting the acceleration, put it here, your answer will be 0.4 meter. You need to calculate this value s. Fine. Acceleration from here, v is given to you, u is your initial velocity. Fine. So now let us move to the next question, that is question number 73. A mass of diatomic gas, that is gamma is equals to 1.4 at a pressure of 2 atmospheres is compressed adiabatically, so that its temperature rises from 27 degrees Celsius to 927 degrees Celsius. The pressure of the gas in the final stage will be. So for diatomic gas, which formula you are going to use out here? So we know that the pressure P will be equal to, since it is for 2 atmospheric pressure 2, then T2 divided by T1 of gamma, that is 7 by 2 for diatomic gas. So 2, how much is T2? T2 is your value given to be 1200 Kelvin, 9, how much? 927 degrees Celsius. If you convert it into Kelvin, how much you will get? 1200 divided by given 27 degrees Celsius. So if you want to convert it into Kelvin, it will be 300 Kelvin divided by 7 by to the power 7 by 2. Now if you solve this one, the right answer for this one will come out to be 256 atmospheric pressure, 256 atm. Now let us move to the next question, that is question number 74. A charge q is uniformly spread on a thin ring of radius r. The ring rotates about its axis with a uniform frequency f hertz. The magnitude of magnetic induction at the corner of the ring is. So the magnetic induction at the corner of the ring we will find out, but before that, how much is the magnetic field at that point for a circular ring? It will be mu naught I by twice of r. So this I can be, now this current can be written as charge multiplied with the frequency divided by twice of r. So the option is coming very smoothly, that is option number 3, mu naught qf divided by twice of r.